Solutions for GATE 2013. The topic is electron devices. In that one we are discussing about the 2 mark questions. The first 2 marks question is, this is the question. Read carefully. The question is related to the Zener voltage regulator circuit. In the given circuit, the knee current of ideal Zener diode is 10 milliamperes. To maintain 5 volts across the load RL, the minimum value of RL in ohms and minimum power rating of the Zener diode in milliwatts respectively. A 125 and 125, B 125 and 250, C 250 and 125, D 250 and 250. The question is again, in the circuit shown below, the knee current of ideal Zener diode is 10 milliamperes. To maintain 5 volts across the load RL, the minimum value of RL in ohms and the minimum power rating of the Zener diode in milliwatts respectively are. The correct answer for this one is B. Minimum value of RL is 125 ohms and minimum power rating of the Zener diode is 250 milliwatts. Let us calculate how these two happens. So take the diagram. This circuit is Zener voltage regulator, a simple Zener voltage regulator. Assume the currents Is and Iz as shown. Is is source current, Iz is Zener current. Assume like this. Is and Iz as shown. And Vs is nothing but supply voltage, that is 10 volts it is given. Supply voltage is not variable, so that it is a constant, that value is 10 volts. And Vz, that is also treated as voltage across RL, which is nothing but V0. So V0 is also constant, Vs is also constant. So Vs and Vz both are constant. So the current flowing through this 100 ohms also constant, that is 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 constant. So the value of Is can be calculated across. Is is current flowing through this 100 ohms. Voltage difference between this 100 ohms divided by 100 ohms will give the actual current of Is. So Is is equal to Vs minus Vz divided by Rs. Vs is 10 volts, Vz is 5 volts divided by Rs 100 ohms. So Is source current is 50 milliamperes. So 10 volts source is supplying 50 milliamperes of current, which is flowing into Zener diode as well as load resistor. So we can write this constant Is current as Iz plus IL, but by that time we can write the equations in this way. The total current Is, at most it can be the minimum Zener current required to work it as Zener voltage regulator, plus the rest of the things is going into the load, so that will be treated as maximum load current. So Is can be written as Iz minimum plus IL maximum. Otherwise Is can be written Iz maximum plus IL minimum. But in the question what was given is knee Zener current, ideal Zener knee current as given as 10 milliamperes. Knee current of Zener diode also treated as Iz minimum, that is minimum Zener current required to keep the voltage regulator proper operation. So from this one we can calculate IL maximum. IL maximum is Is minus Iz minimum, that is 50 minus 10, which is nothing but 40 milliamperes. Since IL is maximum, RL will be minimum, so that RL minimum is nothing but output voltage divided by IL maximum. Output voltage is same as Zener voltage, so that 5 divided by 40 milliamperes is nothing but 125 ohms. So the right answer for RL minimum is nothing but 125 ohms. Minimum power rating of the Zener diode. So Zener diode should not break down whenever it is acting as voltage regulator, so that we don't know whether the current flowing through a Zener diode is minimum or maximum. So we should take the Zener diode tolerable limit as maximum Zener current to be acceptable, so that the minimum power rating is going to be calculated like this: Vz into Iz maximum. So the current flowing through Zener diode will be maximum whenever there is no load is connected. No load is RL is equal to infinite, that implies IL is equal to 0 milliamperes. By that time entire Is will flow through this Zener diode, that is the maximum current. So Iz maximum will be equal to Is whenever RL is equal to infinite, that is IL is equal to 0 milliamperes. Now calculate Pz minimum. Minimum power rating of Zener diode is Vz into Iz maximum. So 5 into 50 milliamperes, that is 250 milliwatts. So minimum RL required is 125 ohms and minimum power rating is 250 milliwatts. So the right answer for the given question is B, 125 and 250.